Okay, start a little bit with solving equations. So let's go to page 8. And I'd like to just do the bottom half here. Let's do 4 through 7 on page 8. Okay. And these are all going to be expanding. So I'll work through these as you guys are working through them at the same time. Does anybody still need this page? Okay. All right, so page 8, let's look at 4 through 7. Okay, so here's number 4. Log base 2 of m to the 4th over 8n. So we see that the m to the 4th and 8m are divided, so we can do quotient property. Oh, I'm sorry. Let's see. The 8 and the n are separate, so we're going to separate them as well. So anything in the numerator is part of a positive log term. Anything in the denominator will be part of a negative log term. So I have 3 terms to separate the m to the 4th, the 8, and the n. And so typically when we're expanding, we always look to see if we can apply product and quotient property first. And then once they're all separated, we can take care of the power property. We can bring those exponents down in front. So the only exponent that we can bring down is that 4. So we'll bring that 4 down. Okay, number 5. Why don't we resolve the radical first? So it just feels a little bit cleaner if I just distribute the exponent through and I can just kind of separate them to begin with. So 10 to the 1/3 and g to the 2/3, right? We're multiplying distributing the exponent through the parentheses. And now we can apply product property, right? These terms are being multiplied. I can separate them using product property. Anything that's multiplied, I can think of it as adding 2 logs. keep expanding by bringing the exponent down. Okay, number 6. Now the u minus 1, we can't do anything. I mean, we can't separate them. Okay, so u minus 1 is just going to be one thing because we can't separate anything that's addition or subtraction, but we can separate the v to the 5th from the w to the 3rd. So numerator is part of positive logs. Denominator will be part of negative logs. Okay, number 7. The hidden base is log base 10. And I can rewrite that denominator using rational exponent, 3a minus 1 raised to what power? How do I rewrite 5th root? 1/5. Okay, so we have 3 things to separate. Once we have every term separated, we'll go looking to see if there's any exponents that we can move. We can. There's 2 exponents we can move to the front. Okay, any questions with page 8? Now, let me recap the steps here for number 7. So notice number 7, we're expanding. We're either using product or power property, product or quotient property to separate each of the terms. And then we're going to bring all the exponents down if possible. Okay, so this is the expanded form. Yeah.
When we get the properties.
Yeah, we gotta know them. Yeah, know them. Yes.
On number 5, where is
Oh, sorry, I miscopied it. It should be log base e. My bad. Thank you. Yeah, I copied it from the above problem. I did not make that adjustment. It should all be log base e for number 5. Okay, so we know how it goes to expand. So now condensing, let me talk about condensing. Condensing is what we're going to do on the next page. We're going to be starting here, and we're trying to make our way back to our starting point. So let's just kind of think about our steps here. The way we bring this back to our starting point is we're not going to look to combine anything yet. We're going to start off by working with our coefficients. So we're going to push the coefficients up as exponents. So we're going to push it back. So when we're going backwards, we're going to bring the 2 up, make it a squared, bring the 1/5 up, make it to the 1/5. And then once we're here, to put everything back, we got to decide where does the a squared, the b, and the parentheses live. The a squared and b are both part of positive logs, so that's going to go in the numerator. And the 3a minus 1 to the 1/5 is part of a negative log, so it's going to live in the denominator. And so that's how we put everything back from an expanded form. Okay, so we look to do power property first, and then we merge them together with product and quotient. Okay, so let's go to page 9. And just like before, let's do the last 4 problems here, so 11 through 14. So when you're condensing, bring the coefficients up first, and then worry about the product and quotient. Okay, so here, we're trying to get it all under 1 log, but let's take care of the 1/2 and the 3 to begin with. Now that I brought all the exponents up front, above, now I can focus my attention on trying to decide where can I put these terms under 1 log, expression. So I know it's going to be log base 5. I got to decide where the terms go within my numerator and denominator. Okay, where's the 36 to the 1/2 go? Up. Okay, where does the r go? Up top. Where does the p cube go? Below. Okay, so when you put everything in, you don't put any plus sign or minus sign. Okay, so everything will be converted to multiplication. So we don't want to say 36 to the 1/2 plus r and then a minus p cube. Okay, no positive, no plus or minus will show up in your parentheses. Okay, everything will be multiplied or divided. We can do a little bit of cleanup. What does 36 to the 1/2 mean? Square root of 36, which is 6. Okay, we go a little further here. All right, try number 12, and I'll work through at the same time you guys do. The 9 squared goes above, and I just made that 9 squared into 81. Okay, for 14, I think the parentheses makes it more confusing, so I'm just going to distribute through and then handle it from there. Okay, I'd like for us to be able to practice doing this without a calculator. So 32 raised to the 2/5, it seems like a complicated thing, but 32 to the 2/5 is the same thing as 32 to the 1/5 squared. Okay, if I separate it this way, taking care of the roots is easier. There's the 5th root of 32, which is 2. And I know that 2 squared is then equal to 4. Okay, and square root of 9, you know 9 to 1/2 is square root of 9, which is 3. So okay, so page 10, let's work through page 10. And if we can get through it with a few minutes left, I want to see if I can introduce a little bit from page 12, solving exponential equations, which you already know how to do. Just want to be able to go a little further with that concept. But let's look at page 10. Okay, does anybody still need this page? Okay, so you're just condensing and expanding on the next page. So what you're going to do is you're going to expand, put your answer below, and then check to see which answer is going to be the one that matches your answer, which one is going to be the correct one. Okay, we don't have to go through the trouble of explaining the mistake on the wrong answer. Let's just identify the correct one. Okay, so. Okay.
Just, that one.
Yep, yep. So we talked about how anything in the numerator is going to be part of a positive log. Anything in the denominator is part of a negative log. So answer B is correct. Now, number 2 is a little bit misleading here. Let me ask you this. Is log of A over 4, is that the same thing as log of A over 4? Are these the same? No, okay. So this 4 is not inside the log. So we want to think of this 4 as really a coefficient of 1/4. Dividing by 4 is the same thing as multiplying by 1/4. And if I see it's a little misleading written out in this form, it kind of makes you think that it's this, but it's not really inside, it's outside. This is the same thing as 1/4. And if I see that 1/4, I want to condense it. Where can I put that 1/4? Up as what's sitting as coefficient now, we can move it up as exponent. Yeah. So if I move it up as an exponent to condense it, this becomes log of A to the 1/4, which is the 4th root of A, but this matches with answer choice B. All right, so this is not the same thing as this here. Okay, keep going, expanding. Number 7, we talked about how we can rewrite an exponential form as log form, right? As log form, we can write it as log base 5 raised, or log base 5 of 100 is equal to x, right? Go around in a circle and pick up values along the way. Convert to exponential form. Log base e of x is equal to 2. Log base e of x is the same thing as saying natural log, ln, as shorthand form. We know that these are equivalent, just a shorthand form of our answer. This is a special property that says if the base of my log and the value matches, they cancel each other out, and the only thing left is that 2x. Okay, page 11 is more of the same. I want to do a little bit of an introduction into solving exponential equations. We've seen it, but we're just going to kind of delve into it a little further. So page 12. Just like to be half a day ahead, just so they can have Friday as a full review day. Okay, are we good with page 10? Mhm. Five, yeah. So this fifth root of z squared is same thing as z to the 2/5. So any number that's to the right is going to live in the numerator of the exponent. Any roots that's to the left is going to live in. So expanding means I'm going to push any exponent down in front. So I'm going to bring that 2/5 down in front. And log base e is the same thing as ln. So I wrote that as ln. So 2/5 ln z is the same thing as 2 ln z over 5.
I got you.
All right, page 12. So a couple of days ago, I highlighted the fact that if I can get my bases to match, I can take away the bases and just focus on setting the exponents equal to each other. That's the same process here. I'm going to work to get my bases to match. And once my bases are matching, then I can do away with it and just focus on looking at the exponents to solve. So there's a bit of a review here. 32 raised to the x plus 3 is equal to 4 to the 2x plus 10. We want to find a common base that both can be raised to. So what is the common base that both 32 and 4 can share? Base 2, right? So 32 is 2 to what power? 5th. I'm just making that substitution and then putting everything down from the original problem. Just changing that 32 to 2 to the 5th. Okay? And then 4 can be written as second. So I'm making that substitution, but then I'm bringing back that 2x plus 10. So now that my bases are matching, I'm able to focus my attention on just looking at the exponent and solving that equation and solving for x. So distribute the 5 through. Distribute the 2 through. And now combine like terms. 5x minus 4x is 1x. 20 minus 15 is 5. Okay, good. Number 2. What's a common base that I can get both sides to share? 3. Yeah. So 3, if I want 3 as a common base, I know 1/3 is a little bit out of place here. But 1/3 to 2x is the same thing as what? 3 to the what? Negative 2x. So this is really 1 over 3 to the 2x. If I want to bring that up to the top and still manage to not change the overall value, I can just put a negative in front of my exponent. Okay, how can I represent 81 with 3 as the base? 3 to the 4th. And put everything down from the original problem. Okay, so now the bases match. I can make those go away. Just solve the exponent equation. Put the x's together. Minus 4x on both sides. I get negative 6x equals negative 12. Divide both sides by negative 6. X equals 2. Now, in a similar way, if I can get both sides to show log base b, I can apply that same process. Just like how I can remove the same base from both sides and just focus on the exponent, if I can get the two sides to show the same base, I can drop the logs and just focus on my expressions. Now, we can only do this if there's a one-to-one property. That means even though these are all log base 4, I gotta have one log on one side and one log on the other side before I can start removing logs. So the left side is ready, but the right side is not quite ready. So which property can we use to merge these together? Product property, right? I need a one-to-one log equals log before I can start removing it. So if I start moving it here, I'm going to miss out on the property that needs to occur. So I'm going to first merge the two logs together. Left side stays. So I need to merge the 3 and the x minus 2 together. It end up being multiplied. So this is product property. So log of u plus log of v is equal to log of u times v. So now that I have a log to log one-to-one property, I can make those go away and just focus my attention on just the expression that's remaining. Okay, distribute the 3 through. Subtract 3x from both sides. Divide both sides by negative 2. Okay, the bottom of the page digs into more of properties with using calculator. We'll save that for tomorrow. We'll focus our attention mainly on 10.04. Thank you. Okay, so let me go ahead and see if I can check pages 8, 9, 10, and 12. 8, 9, 10, and 12.
It's not gonna be other than that. See what I got. It's a they said they want. They what? They said they want. They want a small.
What did you do?
They talk. Dynamic. They want no one that you want. I was thinking. Oh, so it's like except for one word, like one word. I was like, what? It was too ice. Ice. Oh. He said like cheese.